We are now going to begin studying about polyhedron. And a polyhedron is a three-dimensional shape made up of sides and base and top of polygons. So the first activity will require the use of a standard size business envelope. So if you will get one of those and then continue with the video. We will need a straight edge and we will need scissors. So the first thing that we will do with our envelope is to make diagonals with a straight edge. So a rectangle has two diagonals. So we're going to draw those. Now we're going to do some cutting on our envelope, and before we do that, there are a couple things that I want you to do. First of all, I want you to find the perimeter of the envelope. And because it's easier to measure in centimeters, let's measure to the nearest tenth of a centimeter. And then I want you to find the area of the envelope, and again we're going to measure to the nearest tenth of a centimeter. Now remember that the perimeter will have units of centimeters and the area will have units of centimeters squared. So go ahead and find the perimeter and area of your envelope. Okay, after we do that, you have the top. See where the top flap is? That needs to be turned up. The top flap turned up, or the opening turned up. And this section of the envelope we're going to cut away. Alright, after you have that cut, we're going to make a fold along the vertical. So I'm going to be mapping the side to the side and make a crease. Turn it over and fold again so that it's a nice sharp crease. So you may want to do that a couple of times, turning it back and forth so it folds easily. The crease is nice and crisp. Okay, next I want to fold on the diagonal. And again, I'm going to do that several times, folding it both ways. So there's a good fold, and then this diagonal I'm going to fold as well. So we've made 3 folds several times each time so that they fold easily on those lines. And we have our center fold as well. Now I'm holding this up and I'm going to open the envelope. I'm going to take the right side and I'm going to put it inside the right side is going inside the envelope. And just work around with it a little bit until you get it to fit in there. And then if you have tape, you can tape the sides together. And what you've created has 4 sides that are made of triangles. And 4, we can use the prefix tetra and we use hedron as the base word. So we have tetrahedron is what you have created. Now in this tetrahedron, I'm curious as to how the area changes and how the perimeter changes, because the perimeter will be found by looking at the edges. So this is called a face. The triangle is the face, and where the two triangles intersect is called the edge. So you will need to measure all edges and add them together to get the perimeter. Then you will need to find the area of each triangle to find the area. So I want to know how the perimeter changes and how the area changes from the original envelope. Now, when you are finding the area of a triangle, you have to use the base times the height. We have a line where we made one of our folds that will be the height that you will use on the tetrahedron. So here is our height line. You will have to measure it. And here will be our base. So you know that the area of a triangle is base times height divided by 2. So you will do that for all triangles. The height will be, and we don't have a line on this, but we know that the height is going to be the perpendicular distance from the vertex to the base. So this is our height, sometimes called altitude, and this is our base. So you find the area of all 4 triangles and add them together. Remember, the area will be in centimeters squared, and our perimeter will be in centimeters. Now, I want to talk about some other terms that are dealing with the tetrahedron. If I have the tetrahedron sitting like this, the top where the vertices meet on the triangles is called the apex. The perpendicular distance from the apex to the base is the height of the tetrahedron. But for finding the surface area, you would use this height, which we call the slant height. Because it's the height of the face. It isn't the height of the tetrahedron. The height of the tetrahedron is the perpendicular distance from the apex to the base. All right? If the apex is centered over the base, which for mine it is not, The apex is not centered over the base. Depending on the size of your envelope, yours might be, but mine is not. And if it is centered over the base, it is called right. If the apex is not centered over the base, it is called skewed. Okay, to conclude this activity, what you are to send to me is the perimeter of the envelope and the area of the envelope. Then you are to send the perimeter of the tetrahedron and the surface area of the tetrahedron. Last, you will compare. Are they the same? Is the envelope greater? Is the envelope smaller? And attach that in Blackboard.